This video will cover section 1.3, linear equations in two variables. In this section, we are going to review or learn how to find the slope of linear equations. And we're going to learn to do that in several ways, by numerically, algebraically, or by just looking at the graph. So we could look at a table, that would be numerically, graphically by looking at the graph and counting how many from one point to the other, what is the rise over run. And we could also do it algebraically, by substituting two points, the coordinates, into this formula. But we're going to review all of this in a second. So I want to just make it very clear that the slope is it's actually the rate of change between 2 points for this section. And based on that slope, we're going to be writing linear equations in two variables. Those two variables will be x and y. And then we're going to look at different forms of writing the equation. They're all listed at the end of this presentation. So we're also going to be using the slope to identify parallel and perpendicular lines. Parallel are lines that are parallel like that, they never intersect. Perpendicular will be intersecting exactly at a 90 degree angle, just like the XY axis. We're also going to be using the slope in linear equations to model and solve some real life problems. So we'll have some application at the end. So let's get started. So the first form that we are going to be looking at is what we refer to as the slope intercept form. And we call it that because we have here the slope and here we have the y coordinate of the y-intercept. So both m and b are numbers. And remember, we covered this earlier, that a y-intercept is a point for which the x-coordinate is a 0 by default. That's why it's a y-intercept. And then the other, the y-coordinate is going to be represented by that letter that we are just generalizing with the letter B. So that would be the first one. And so if we were to let that, to find a y-intercept, this is how you will find a y-intercept. You already know that the first step is to let the other letter, which is x, equal to 0. And so if we start with this form, y equals mx plus b, which is here, the one that we call the slope intercept form. So if we start with that and then we replace x, like it says here, with a 0, then we will have m times 0 is equal to 0. And so we have that y is equal to b. So in other words, the y-intercept is always going to be that point, 0, comma b. And the slope, I already told you, the definition is the rate of change, the average rate of change, I should say. But it also tells you the steepness of the line. And if you take more math classes, then you will learn other meanings for that. But for now, let's just concentrate on linear equations. So the simplest mathematical model for relating two variables is the linear equation in two variables. Those two variables are going to be x and y. Those are the two variables, and we're going to be relating one to the other. And the equation is called linear because the graph is a line, and this could be a slanted line. It could be leaning to the right, and that means that we have a positive slope if it's leaning to the right. A more correct way to say that it's leaning to the right will be to say that it is increasing. And it's also, we could say that the line is, it rises to the right. Now, we always read graphs from left to right. So if we look at the other graph, you could see that the line is falling from left to right. So we could say the line falls, and that is because the line has a negative slope, or we may say it's leaning to the left. Leaning to the left. But remember, a better way to say that will be that it is decreasing. And we're going to start using these words to describe graphs, increasing and decreasing. So again, we have the slope-intercept form because we have m is the slope and b is the y-coordinate of the y-intercept. Okay, so we could also see here graphically the y-intercept is going to be located here on the y-axis, and the slope is going to tell us how many units we went, the steepness of the graph will be. For example, how many units it went up or down from one point to another, and how many units it went right or left from one point to another. But we're going to do some examples in the coming slides. So here's just a summary of what we have been describing. So positive slope, the line will be rising. Negative slope, the line will be falling. And we also refer to that behavior as increasing and as decreasing. We have the y-intercept there and there, always on the y-axis. Now, on this next example, we're going to look at a line that it will not be slanted, it will be vertical, but it is still a linear equation. Not a function, but just a linear equation. And we will learn why in the following, the coming sections. So sometimes, if, for example, if I was to use those 2 points and create a table of values of x and y, you could see that for both of those points, when the x is equal to 3, then the y values are different. We have 5 and 1. And so in that case, the value for y, it's irrelevant. It doesn't really matter. What it's going to happen is the x will always be 3. So any point that we pick on that same line is going to have the same x value. And so when that occurs, when the x values repeat, and that's why I say it's not a function, but we will cover more of that. So when the x values repeat, then the equation of that vertical line is given by x equals to a number. So in this case, the equation will be x equals to the number 3. Why 3? Because that is the number that it is repeating. And so that's going to tell us what the number is. Now, in this case, and we will see why in a minute, the slope is undefined. So that could happen. So remember, just to review, we had positive slopes. We could also write this as m greater than 0. And we use the letter m because it refers to, it's the first letter of a French word that refers to a mountain. So that's why. So m greater than 0 means the slope is positive. M is less than 0 means the slope is negative. So whenever you see a vertical line, that is because the slope is undefined. Not equal to 0, that will be a horizontal line. And in fact, let's just draw that one. We could have something like this. And that could be, let's say this y value is a 4. So the equation for that will be y equals 4. And in this case, the slope is equal to 0. So in other words, m is exactly 0. Not greater, not less, but just at 0. We'll see more examples. Now, since the y value here, 5, 4, 2, 1, I remember saying it's irrelevant, we cannot write a vertical equation with y. And so we just use the x equals to a number. And that's just how it is, because m will be undefined. Okay, so we're going to sketch the graph of this linear equation, and we're actually going to do, we practice making a table and then plotting the points from the table. I also show you how to graph it on decimals. And what I want to show you now is how to use the way that it is written, because we have the slope. And we also have the y-intercept. So we're going to say that the slope is equal to 2. The slope, it is always the coefficient of the x value. Always. And the y-intercept as a point, remember the x is always 0. And then the y coordinate comes from that number, the constant term of the linear equation, which is 1. So that will be the y-intercept. So the first thing I'm going to do is plot the y-intercept, which is right here on the y-axis, coordinates 0, 1. That is the y-intercept. And then based on the definition of the slope, we could also say that it is 2 over 1 because it's an integer, so the denominator is a 1. So that means that the rise is going to be 2 and the run is going to be 1. Both are positive, so for that reason, we're going to move 2 units up and 1 unit to the right, because the 2 is positive and the 1 is positive. From where? From the y-intercept. So this is going to be like our starting point. Okay, so we move 2 units up, 1, 2, and then 1 to the right. So our new point will be there. We could do that again, 1, 2, and 1 to the right. if we want to get a more precise line. On web assign, you could also, I believe you also need 2 points. And I want to show you guys something. So if we have +2 over +1, it will be the exact same as having -2 over -1. So in that case, to represent the rise over run will be 2 units down and 1 unit to the left. So I'm going to demonstrate that from the y-intercept again, but now I'm going to use those directions. So 2 units down does 1, 2, and 1 to the left. I can do that again, 2 down and 1 to the left. And as you can see, we're going to get the exact line. Or meaning like all of our points will be on the line, which it doesn't really matter if your slope is +2 over +1 or -2 over -1. The reason is that if you divide a negative by a negative, you get a positive. So that is a way to graph our linear equation. Now the next one, we do not have an x. We don't have 2 variables. We only have 1 variable. So if I make a table of values, and I don't want to confuse yourself, so I don't want you to confuse yourself. So if I make this x and this y, okay. So let's say I want x to be -3, I want x to be -2, -1, 0, 1, 2, and 3. Since I do not have a place to substitute the x value there, so all of my y values are just going to be equal to 2. And so if I do that, I'm going to plot the points that will come from there. So in the form of a coordinate pair, we'll have -3, 2. We'll have -2, 2. We'll have -1, 2, and so on until 3, 2. So I'm going to just plot the points. And I just chose the x values to be purposely on the left and the right side of 0, but I could also choose very large values of x, like 10 or way larger, and the y value will always be equal to 2. So all of those points will have the exact same, they will all have the same y value, which is, of course, 2. And I'm just going to go ahead and draw arrows at the end of each side, because that's just how it is. The domain, the x values, the choices that we have for x values are infinitely many, from -infinity to +infinity. In fact, I should do the same for this graph. Draw some arrows at the end, at each end of the line. So there you have it. That is a linear equation. This one is a function, but we'll discuss later why. And it is, of course, a horizontal line. So, for example, on your homework, if you are asked to write the equation of a horizontal line that passes through the point -3, 2, because of the word horizontal, you should make the relation that you will use the number 2 as the number, and the letter or the variable that will go with it is y. So you need to remember that. Y equals to a number is always for horizontal lines. And like we saw here, x equals to a number is always for vertical lines. Okay, now we're going to graph the next equation. And as you could see here, that this one is written in in standard form. And so, or is it general form? I'm not sure, but at the end of this section is we have a summary. And okay, so one thing I can do is isolate the variable y, which will be pretty smart to do. It will be the easiest, because at that point we know that we could use the slope and the intercept to graph it. So I'm trying to make it look like the slope intercept form, which is here. So if I do that, it will be this positive x. If I take that across, the equal sign is going to be, instead of adding, it will be subtracting. Not a 2, but an x. Negative x. And of course, we could rewrite this with the x first, but it still keeps the negative sign. So negative x plus 2. All right, so from here, the implied coefficient of the negative x is a -1. So we know that m is equal to -1. And because it is an integer, we have put a 1 for the denominator. So in this case, we could say that it's going to go 1 unit down and 1 unit to the right. And we say down because the number on top is negative. This always tells you the change in the y and the change in the x. The little triangle, it represents delta, which means change. So that's why if the change is negative, you are going to move down. And where is going to be our starting point? Well, that one is going to come from the y-intercept, which is here. So we're going to have that the y-intercept, it's going to be as a point 0 by default, comma 2. And that's going to be our starting point. So we start here. And then using the slope, so we're going to go 1 unit down and 1 unit to the right. So it's going to be there. I'm going to do it one more time. 1 unit. Actually, no, I did this wrong. Sorry. 1 unit down and 1 unit to the right. And then again, 1 unit down, 1 unit to the right, 1 unit down, 1 unit to the right. And I can keep doing that all day, but I won't. But let's just make an observation here that if we put the negative at the bottom, those two numbers are exactly the same. It doesn't really matter where the negative is, as long as it's only in one of those, either numerator or denominator. So if I want to use this form of the slope, since the change in the y is positive, that means it will go up, 1 unit up. And since the denominator is negative, then we're going to have the run is going to be to the left, just like the number line. So from the y-intercept, I'm going to go 1 unit up and 1 to the left. 1 unit up, 1 to the left, and as you can see, the points are going to be on the same line still. I'm going to try to make a nice line. Okay, maybe there. I'm gonna try again. Oh, no. Okay, I'm gonna zoom in. Maybe I can do better that way. There we go. So we're touching all of our points. So it's a good line. And then let's put those arrows at the end because we know that the x values that are linear equation, we will start calling a linear function pretty soon. The domain, the x values, can go from negative infinity to positive infinity. So now let's go ahead and we already cover how, given the equation of the line, we can find the slope. That is what we did by looking at the equation. Where was our first? Here. Here we said the slope is a 2. So here we said the slope is 0. Actually, we should write that down. M, remember, for mountain, slope is equal to 0, the rate of change. So if that is the slope, by looking at the equation here, we said the slope is -1. So now we are going to practice how to find the slope with a formula. And so if we consider the 2 points that we have here, we have point 1, which has the coordinates x sub 1 and y sub 1, and then we have point 2, which has the coordinates y sub 2 and x sub 2 and y sub 2. So to calculate the difference, the change in the y's, we have to calculate the difference. And so that will be a subtraction like that. And if we have to calculate the change in x, we will use the difference between the x values, so x sub 2 minus x sub 1. So remember that this is the change in y divided by the change in x. And we will see that on the next slide as well, but here's the graphical idea of calculating the change. So we are going to see how far the graph go up from this point to this point, and that is what we have here, the change in y. And then we want to calculate how far the graph move horizontally from this point to this point, and so that is right here. So remember the change in y divided by the change in x. So we have a summary of what we just said. And so we want to see how the graph behaved in the vertical direction. So vertical direction. And then we want to see how the graph behaved in the horizontal direction. And please always remember that it is the y will always be on top. And that's why we call it the rise over run. If you switch the order, like what you have here, if you were to write the difference of the x's on top and the difference of the y's on the bottom, that will be completely wrong. Okay, so let's just not get used to that. Also, it's important to notice that x sub 1 and x sub 2 cannot be equal, because if that happens, the denominator here will be equal to 0. And so things that are divided by 0 are undefined. So any number divided by 0 is undefined. And so for that reason, we cannot let the x be two different x's. I'm sorry, like the x values from two different points to be equal. In that case, the slope will be undefined. Remember, we're talking about the formula of slope. Now, if we look at the vertical line that we had over here, again, remember we said the slope is undefined. Well, that is because the x values with two different y values, if we take the point 3, 5 and the point 3, 4, then when we use the slope formula, it will be the y values 4 minus 5, and then for the x values, it will be 3 minus 3, which will give us -1 over 0, and this is undefined. So for all vertical lines, the slope is undefined. And for all horizontal lines, the slope is equal to 0. So here on the next slide, we have two correct ways to write the formula for the slope and one incorrect way, aside of the one that I show you here as well. So let's label this one as incorrect. Never, and it's a very common mistake, but please don't do it. Never put the x values on the top of the fraction. So you could consider this point here to be x sub 2 and y sub 2. And you could think of this point as x sub 1 and y sub 1. So when we have like actual numbers, you could label them whatever you want, as long as you don't mix and match. So what we mean is like, don't call this point x sub 1 y sub 2. That will not be okay. So the two subscripts need to be exactly the same. So this will be wrong. So if you decide to start with the second point values, that's okay. But if you decide to start with the first point values, that is also okay. So that will be kind of like an equivalent way to explain that it doesn't matter which point you label, x sub 1, y sub 1, and the other point x sub 2, y sub 2, as long as you don't mix the two subscripts. So if you start with y sub 2 and x sub 2, then you must continue with y sub 1, x sub 1, and for the other one, then you continue with y sub 2 and x sub 2. So here, just to make sure that you're understanding, if you start with y sub 2, then it will be completely wrong to start with x sub 1. That will be a mistake. And if you start with, if you finish on the subtraction here with y sub 1 and then finish here with x sub 2, then this is why this is completely wrong. So that is wrong. It's incorrect, and so is this one, incorrect. And this one is okay, as long as the x values are not equal. So, okay, so I erased that. So let's just make a little notation here that says if x sub 1 is equal to x sub 2, then m is undefined. M being the slope. So we're going to practice, well, here's an example of how making the formula y sub 2 minus y sub 1 and this x sub 2 minus x sub 1 you get the exact same thing as if you would say y sub 1 minus y sub 2. And then you follow on the denominator. You will start with x sub 1 minus x sub 2. So that will happen if, of course, we make this point x sub 1, y sub 1. So you notice same subscript because they're both in the same point. And then this will be x sub 2 and y sub 2. So you could see the substitution here. For y sub 2, we have 7 minus, that is part of the formula. The two negative signs are part of the formula. And then we have minus y sub 1, and y sub 1 is 4. So we have it here. And then we have x sub 2, which is 5. And then minus x sub 1, which is 3. So 7 minus 4 is 3, 5 minus 3 is 2. The other example here is we start with y sub 1. So that would be the 4 from here, 4. And then we continue with minus y sub 2, which is 7. And then for the denominator, we have, we start with x sub 1. And x sub 1 is coming from here. So we have 3, that's x sub 1, minus x sub 2, which is 5. And so here we get negative 3 because 4 minus 7 is negative 3. 3 minus 5 is negative 2. But recall that when you divide two negative numbers, you get a positive number. So here's another proof that you could have two negatives dividing and end up with a positive fraction or rational number. So now let's go ahead and practice the how to find the slope on this points with these 2 points. And so remember the formula is x sub 2. Oops, that's completely wrong. Remember, never put the x on the top. So y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So I'm going to consider this to be my x sub 1, y sub 1, x sub 2, and y sub 2. So we will have m is equal to 1 minus 0 over 3 minus negative 2. Now remember that the formula comes with two negatives. The other negative is coming from the actual value of x sub 2. So once you have negative numbers that you're going to be substituting, you have to be extra careful so that you don't overlook them. So here, double negative is like you have negative 1 multiplying negative 2, so that will be positive 2. Let's not forget about the 3. So 3 plus 2. So the slope here is going to be 1 over 5. Since both numbers are positive, this means that from one point to another, you could say move 1 unit up and 5 to the right. Now let's see what happens with the next one. So we have here x sub 1, y sub 1, x sub 2, y sub 2. So following the formula again, and I'm going to write it because why not? So x sub 2 is 2 minus y sub 1, which is 2. Oops. Over x sub 2, which is 2, minus x sub 1, which is negative 1. So here we get 2 minus 2 and 2 plus 1. So we will have 0 over 3, which is equal to 0. So remember, when you have a slope that is equal to 0, that implies that you have a horizontal line. And when you have a horizontal line, the equation for it is y equals to a number. That number is going to come from the same y value that is repeating here. So in fact, you don't even need to use a formula unless you want to make sure. There's nothing wrong with that. But if you see that the y value is repeating, then you could say that. You could even plot the points and see that they're going to follow the path of that horizontal line. So horizontal lines, y equals to a number. The number comes from the points. Okay, next example. Again, I'm going to write the formula. So m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So I'm going to just start substituting. This is going to be my x sub 2, y sub 2. So it will be negative 1 minus 4. Remember, this is x sub 1, y sub 1. Now, x sub 2 is 1 minus x sub 1, which is 0. Negative 1 minus 4, both are negative, so we add the absolute values but keep them negative. So negative 5, and then on the bottom 1 minus 1 is 1. So this is equal to negative 5. If we want to talk about how this is going to behave, it will be 5 units down, 1 to the right. Okay, and the last example from this slide is going to be, again, I'm going to write the formula. This is one of those formulas that you definitely want to remember, especially if you're going into any math, science, engineering, computer science, any of those fields. Because if you have to take pre-calc 2 and calculus and other classes, it's just very useful to know it. So y sub 2 is going to be a 1 minus y sub 1, which is a 4. Now here, if you notice, the x values are both the same. So at this point, I can tell you that the equation of the line is going to be x equals that number, which is 3. However, I'm just still going to finish the problem. So x sub 2 is 3 minus x sub 1, which is 3. So what's happening here is that the numerator is going to be equal to negative 3, but the denominator is going to be equal to 0. And for this operation, we say that it is undefined. And we know that it's going to be a vertical line. So that's it for that slide. So now we're going to move on from the slope-intercept form. When I say slope-intercept form, what I'm referring to is this form, y equals mx plus b. We call it that because we have the slope, which is the m, and we have the y-intercept, which it comes from this constant. So we're going to learn a new way to write equations, linear equations. So with that, we're going to use the point-slope form. And we call it the point-slope form because we have the slope, it's right here, m, and we also have a point. And that point, it comes from here, x sub 1 and y sub 1. Now, the x here without a subscript and the y without a subscript, those need to remain there because we want to have two variables just like we do in the slope-intercept form. We want to have two. And so what we have here is just if we were to use the formula for slope, which is the one that we've been using, y sub 2 minus y sub 1 over x sub 2 and x sub 1 minus x sub 1. And we could say that right here, this point, that for convenience, we're just going to call it x and y, like you see it here. And at that point, it's going to be representing what x sub 2 and y sub 2 will be. So if we substitute those into the formula, it will be y sub 2. So I'm just going to place y, and then minus y sub 1, which we just have that. It's just like that point. And then the denominator will have, instead of x sub 2, we're calling x sub 2x. So it's here. And then minus y sub 1. And here's our y sub 1. So we get to that form, which I'm going to rewrite here. And that says y minus y sub 1 over x minus x sub 1 equals m. And you could see how the x sub 1, x minus x sub 1 is dividing the y minus y sub 1. Here, numerator, denominator. So what I'm going to do is take the denominator across the equal sign, and it's going to change the operation to its inverse operation. So from division, it's going to be multiplication. So then it will look like this. Y minus y sub 1 will be equal to m, and we go from division to multiplication of that same denominator. So this will be x minus x sub 1. And that is the exact same thing that we have here. That is the formula. And so that is what we refer to as the point slope. Remember, I already told you why we call it that point, because we have a point that comes from x sub 1 and y sub 1, and we have the slope, obviously, which is here. Okay, so we have here another slide with the same information. The equation of the line with slope m passing through the point x sub 1, y sub 1 is, when we have it here, x sub 1, y sub 1, and we have the slope. And remember, we must have the variable x and the variable y. Okay, so what we're going to do next for example 3 is we're going to find the slope-intercept form of the equation of the line that has a slope of 3, and it passes through the point 1 comma negative 2. And so slope-intercept form, I want to remind you that it's the one that looks like this. Y equals mx plus b. That's the slope-intercept form. But the way we're going to get to it, well, we have the slope, and we can't just substitute the y value that you see here because it's not the y-intercept. For this to be the y-intercept, the 1 will have to be a 0. So it's not going to work. So what we need to do is use the point slope formula, which is the one that we just finished talking about. Y minus y sub 1 equals m parentheses x minus x sub 1. The parentheses means that the m is multiplying both terms inside the parentheses, so we have to be very careful to substitute them correctly. So we have the slope. We're going to substitute the slope in there. And we're going to substitute the point as well, which is 1 comma negative 2. And make sure you substitute correctly the x and the y. So we have y minus y sub 1 comes from here, negative 2, and you notice that it's negative. The other negative is part of the formula. Then m is equal to 3 right here, parentheses x minus, that comes from the formula, and x sub 1 happens to be positive 1. So remember, the negative here, it came from the value of y sub 2, which was negative. I'm sorry, y sub 1. It's negative. So we're going to simplify this, and we will get y double negative here, so that will be y plus 2 equals 3, parentheses, x minus 1. And since the problem is asking us to leave our answer in slope-intercept form, then we will simplify it a little further until it looks like that, like y equals mx plus b. So what I'm going to do next is I'm going to distribute the 3, meaning I'm going to multiply the 3 times x, 3 times negative 1. So that will give me 3x, and then positive 3 times negative 1 is negative 3. So we have y plus 2 is equal to 3x minus 3. Oh, I'm just writing the same thing. So let me do this horizontally. So if I was to subtract 2 so that I can have 0 there, okay, I'm just going to rewrite the whole thing. Okay, so y is equal, no, y plus 2 is equal to whatever we see on the other side. So what I want to do is subtract 2, and whatever I do to one side, I need to do it to the other side. So we're going to say minus 2 here already. And we already know that here this is going to give me 0. So that's why I don't like to write it, because I already know it's going to cancel. And I just like to say what's going to happen from addition to subtraction, right? If you cross the equal sign, inverse operations. And the right side will be 3x. And negative 3 minus 2 is going to happen to be negative 5. So now from here, this is the answer in slope-intercept form. So if the question was, what's the slope? It's 3. We already knew that from here. But the y-intercept, now we know that the y-intercept has the coordinates 0, negative 5. And we can see the graph here. We have the image that is the y-intercept, which is the point on the y-axis. And if you consider the positive being slope, the slope being positive 3, that means 3 units up, 1 to the right. So that will be here. 1, 2, 3, 3 up, and then 1 to the right. So you have your second point right here, which was actually the point that was given to us. The 1, negative 2. Okay, so moving on, the next topic is going to be, well, let me tell you some things that could happen to you while you're doing your homework. You could be given a slope, and instead of being told that a point like that, they could tell you with the x-intercept, let's say that they tell you the slope is negative 2, and the x-intercept is 4. What does that mean? Well, this means that if it's the x-intercept, the y-coordinate must be 0, and the other one is 4. So that is how you can take a point. Or if you're told the origin, then you have the point 0, 0, if it says it passes through the origin. What if they tell you the slope is 0, and the point is 10 comma -4. Well, if the slope is 0, that means that it is a horizontal line. And if it is a horizontal line, then you need y equals to a number. And where is that number going to come from? From the y value of the point. So in this case, y equals -4. So you're not always going to start with the point slope form. What if they tell you the slope is undefined? Well, what that means is that you have a vertical line. And if you have a vertical line, then your equation will be x equals to a number. And if they give you a point, let's say that they say the x-intercept is 5. Well, that point, x-intercept 5, means 5, 0. So then the x value is 5. And that's what will go here. X equals 5. So the next topic is parallel and perpendicular lines. So for parallel lines, we have the case that two slopes are equal. We have to make the distinction that they're going to be non-vertical, and that's because we already said over and over and over that for vertical lines, the slope is undefined. So not equals, but is undefined. I like to abbreviate it like that. So parallel lines, they could be horizontal, that's fine. They could be slanted to the right or to the left. Those are examples of parallel lines. And we have the other case that if they are perpendicular, then that is because their slopes are negative reciprocals of each other. So we have one slope here and the other one is here. Now, what does it mean to be a negative reciprocal? Well, negative means that if this is positive, the other one will be negative. And if we had something like positive, let's say 1/3, then the other slope will be negative. And then the reciprocal part, it means that you flip or switch the numerator with the denominator. So we will have, instead of 1/3, we will have 3/1. But remember, the negative part means that it will change from positive to negative. If we had started with, let's say, -5/4, then and I shouldn't say equal. Those will be, let's say this is M1 and this one here is M2. So if this is M1, then the slope that will be equal to it, perpendicular to it, will be, well, we'll put this 2 together, and then we're going to have this 2 together. And sub 2 will be with the reciprocal of those numbers of 5/4, so it will be 4/5. And because we start here with a negative slope, then the other one will be positive. So it's going to go to the opposite sign. That's what it's going to be. So opposite sign. And then reciprocal means that you will exchange the numerator and denominator. Or if you want a shortcut, think of the opposite. And opposite sign and flip the numerator and denominator. Okay, so let's practice some. Now, I gave you some examples. Let me give you one more. If our slope was, let's say, positive or negative 10. Then remember, if it's an integer, you have to put a 1 for the denominator. So then the slope that will be perpendicular to it will be 1 over 10. You flip the numerator, denominator, one is negative, the other one will be positive. So here to find the, we're going to find this, finding parallel and perpendicular lines. So we have find the slope intercept form. Remember, that is the y equals mx plus b of the equations of the lines that pass through the point 2 comma negative 1. So that point is going to be very important. So it's going to be 2 comma negative 1. And remember, that's going to be representing x sub 1, y sub 1. Now, if you notice, we have two questions. Part A says parallel. And if I scroll down, we could see part B, it says perpendicular. So this is a two-part question. However, for both of those, the point that we'll be using is the same. The point will be 2 comma negative 1. But there are going to be two problems. Okay. So here we want our new line to be parallel to this line here. So this is the original line. This is line 1. Okay. So line 1 is in standard form. We want to write it in slope intercept because we want to know what the slope is. Those are big question. So we have 2x minus 3y is equal to 5. And if I want to solve for y, it's going to be negative 3 is equal to the positive 2x taken across the equal sign. It's going to give me negative 2x. And let's not forget about the plus 5. So from here, the negative 3 is clearly multiplying the y because there's no sign in between them. So the negative 3 is going to come across and the equal sign and it's going to be dividing. So the negative 3 divides both terms, the negative 2x. So I call this splitting the fraction, plus 5 over negative 3. At this point, we could see that we have a double negative, and that will give us a positive. So we're going to have 2 positive 2 over positive 3. I can put the x there. Or I could also write it here, and it is the same thing. Now here I have positive 5 divided by negative 3, so I can just say minus 3. Now, what I need from here is the slope. And since I'm calling this line 1, it's going to be m1. So it's going to be 2/3. So now, to actually answer the question, we want a line that is parallel to line 1. So here for my line 2, the slope m sub 2 is going to be considered equal because we want the line to be parallel. So it's going to be also 2 over 3. Remember that part only because we want the two lines to be parallel. Those two. So then m sub 1 must be equal to m sub 2. Okay, so I'm going to start with, since I have the slope and I have a point, I'm going to use the point slope formula. But I actually need to give my answer in slope intercept form as it says here. So be careful with whatever sign when you do that. So point slope is the y minus y sub 1 equals m parentheses x minus x sub 1. So I'm going to substitute everything that I have here. So it will be y minus y sub 1 is a negative 1. I'm going to put it in parentheses. Then for m, I have 2/3 and then we leave x. Remember that x and y, those are going to be left alone. You don't substitute those. Then minus x sub 1, which is coming from here, that is a 2. Now let's simplify this, double negative, so we have y plus 1 equals, I'm going to distribute the 2/3 here and here. So that's going to give me 2/3 of x minus 2/3 times 2. We multiply numerator with numerator. That will be 2 times 2 is 4. And denominator with denominator, 3 times 1 is 3. So now I'm going to solve for y because I want my answer, or they want my answer in slope-intercept form. So I'm going to take that positive 1 across the equal sign, and it's going to be subtracting. So 2/3 of x minus 4/3 minus 1. Now, a negative 1 in terms of thirds, it's equal to 3/3. So this is 4/3 minus 3/3. And so the final answer will be y is equal to 2/3. And from here, we will be getting minus 7/3. So this is the final answer to part A. Now for part B, we could already use the step where we found the slope of this line. Remember, this is line 1 still. We decided to call this line 2, or I did. So here the slope of line 1, m sub 1, is going to be 2/3. Now the second step is to recall that if we want perpendicular lines, m sub 1 will be 2/3. So therefore, the line that will be perpendicular to it, and I'm going to call this line 3, because we already have a line 2 here. So line 3, the one that is going to be perpendicular, is going to have the negative reciprocal slope. So m sub 3, that's just a label, doesn't really matter. It's going to be equal to the reciprocal, so 3/2. And because this slope was positive, this will be negative. Then the third step would be to use the point slope formula. So y minus y sub 1 equals to m parentheses x minus x sub 1. So we're going to have that x sub 1 and y sub 1 come from here. So y minus negative 1 again. And then now the slope is negative 3/2. So negative 3/2 parentheses x minus x sub 1, which is here, 2. Then we have y plus 1 equals negative 3/2 of x minus 2. So this will be y plus 1 is equal to, we distribute the 3/2 times the x. So negative 3/2 x. And then 3/2 times negative 2. So negative times a negative will be positive. 3 times 2 is 6. 2 times 1 is 2. So from here, we're almost done. We could see that the plus 1 is going to come across the equal sign, and it's going to go from addition to subtraction. But we could also see that how the 6/2 is going to be an integer. So this will be y equals negative 3/2 of x. The 6/2 is actually going to be just a plus 3. In the plus 1, take it across the equal sign or subtract 1 from each side. So it's going to be a minus 1. So the final answer for part B of this problem is going to be negative 3/2 of x plus 2. And that will be the final answer to that problem. So in the last part of this section, we'll cover some applications. And here we could see the slope of a line being interpreted as either a ratio or a rate. And like I mentioned earlier, the average rate of change. But yes, we also consider it we could just call it rate or rate of change, and more specifically, the average. Once you take calculus, you will look at rate of change, but with the word instantaneous rate of change in front of it. And it's similar, but not exactly the same. So again, we're going to use the same formulas, and also consider that when we talk about rate, it could be something like, for example, the amount you get paid, your pay per hour. So in this case, as a slope, it will be something, the amount that you get paid, the money paid, divided by the number of hours that you work. Or we could also think about miles per hour, and that's a very common rate. And here you have miles, or this is the unit, so I should be saying distance. The number of miles that takes you to cover in a certain amount of hours. So, for example, 5, we have that the maximum recommended slope of a wheelchair ramp is 1/12. So that will be our M. And this, I'm going to continue reading. It says, a business is installing a wheelchair ramp that rises 22 inches. So that will be the number on top, the change of the Y values, the vertical change, over a horizontal length of 24 feet. So the question here is the ramp that was being built, and you could see the picture over here, is that ramp steeper than the recommended one? So let's just go ahead and differentiate this. So this is the recommended, so I'm going to call it M sub R for recommended, and the other one I'll just leave it like that. So if I simplify the fraction here, we will have 11 over 12. So if we compared, oh, and I just realized I made a huge mistake. So, oops. The problem here is that I did not pay attention to the units, so don't do that. Okay. So what we need to do first, if you notice, we have two different units. We have inches and we have feet. So let's just convert everything to inches. And so we could say that here we'll have the same inches for both. So the 22 inches here, we'll leave it like that. And then the 24 feet that we have here, we're going to convert that to inches. So because 1 foot is equivalent to 12 inches, we could say that 1 foot over 12 inches is equal to 1. And so that is what we call a unit factor. And I'm going to use that unit factor to convert the 24 feet to inches. So that will be 24 feet multiplied by, and actually I'm going to use the other one because I'm trying to cancel the units. So I wanted to have that on the bottom. So we have 12 inches is equal to 1 foot. So if I do that, and remember I multiply horizontally, so 24 times 12, it is equal to 288, and the units will be inches because here we could divide feet over feet and get a 1. So we say they cancel. So here now if we have everything converted to inches, we have 22 inches for every 288 inches. That will be the rise over run, or the change in the vertical with respect to the horizontal. So I'm going to simplify the fraction. So this is going to be divided by 2. So we have 11 over, and 244 divided by 2, 288 divided by 2 is 144 inches. So to compare them, what I'm going to do is get an approximation. So I'm going to put it in the calculator, 1 divided by 12, and I get 0.083. And then the 3 repeats. For the one that was already built, this is the recommended one. For the one that was already built, we're going to divide 11 by 144, and we're going to get 0.076. So if we compare that, this is an 8 right here, 8. If you compare those two, you could see that the recommended one is the one that is higher, so therefore is steeper. So then the one that was built is not steeper than the recommendation. So I guess they are okay. They will not get in trouble for building that ramp. Now we have the very last problem. I keep thinking that. So it says the sales for Best Buy are approximately 49.7 billion in 2009, and we could see that point is here. And as you notice, it doesn't say 2009, it says 9. And so that's one thing that we're going to be doing. It's very common to just use the last digit or the last 2 digits. So we have for another year, 2010. So in that case is this point here, and we're using x equals 10, or we're calling it T for time. And the sales were 50.3 billion. Using only this information, write the linear equation that gives the sales in terms of the year, and then predict the sales in 2013. So first we need to find the equation. And then after that, we're going to predict the sales in the year 2013. So that will be when x is equal to 13, what will the y value be equal to? But for us to find that, first we need to find the equation. So first thing, we're going to take the 2 points that we have, and the points will be 9, 49.7. And the other point is going to be 10, 50.3. So to find the slope, first, we're going to use the formula y sub 2 minus x sub 2, y sub 1 minus x sub 1. And here, if you notice, we're calling, instead of x, we're using t. So I'm going to just go ahead and change that so you start getting used to seeing other letters. It's not a big deal. We could call this t sub 2, t sub 1. And now I'm going to start substituting. So y sub 2, 50.3 minus 49.7 over 10 minus 9. So I got 0.6 over 1, or we could just call it 0.6 for the slope. And then the second step is going to be to use the point slope formula that I'm writing here. And with this formula, we're going to be substituting. We can take from either point. I'm going to just go ahead and use this one. and we're going to substitute x sub 1 and y sub 1 with that, and then of course you already know the slope is going to be substituted with m. So let's do that. So y minus 49.7 is equal to 0.6 times x minus 9. So here we will get y minus 49.7 is equal to 0.6 times x and then minus 5.4. So again, if we consider this quantity here that is subtracting, take it across. Now it's going to be adding, so we will have y is equal to 0.6x minus 5.4, and then plus, not 50, but 49.7. So the final answer after you combine terms here with the numbers, it will give you 44.3. So that is the answer for that question. Y equals 0.6x. Oh, in this case, I'm sorry about the x. It should be t. I just get confused with that. So when you enter your answer on WebAssign, make sure that you're using the correct variable. If they're using t, use t. If they're using x, use x. Also for y, just try to match the variable from your answer to the one on the question. Okay, here just quickly without examples, we have here a case of extrapolation, and that means that you have a point that does not lie between the two given points. So these are the two given points, as you can see here, and the other point is outside, so it's we call that linear extrapolation. Now for the linear interpolation, we have two given points again, here and here. Those are the two given points, and then the estimated point, it's going to be in between them. So then we call that interpolation. And here the last slide is just a summary of all the equations that we looked at. Very good to keep handy while you're doing your homework. And remember how we look at, not that one, we looked at that one that looked like similar, but it was actually this way. AX plus BY equals C. And this is what we call the standard form of the linear equation. The one that has the constant within the b with the x and the y, that one is called general form. So they're almost identical, but not quite. Also, we looked at some that were just x equals a, that's the vertical line, and the one that is y equals b, that's the horizontal line, and that is because either the coefficient for x or the coefficient for b could be 0, but not both at the same time. And that is based on the definition of the general form of the linear equation. So this is the end of the video.